Okay, we're going to go over a few problems to get ready for tomorrow's quiz on circles, specifically dealing with central angles and inscribed angles. So the first few problems are going to be dealing with central angles, and the definition is the measure of an intercepted arc, an arc intercepted by a central angle, that is, in this case, arc AB. The measure of that arc is equal to the measure of its central angle. So if the measure of the central angle is 81, the arc has to be equal to 81. And that's simply a definition. Next problem. Another diagram that has a couple of central angles in it says if the measure of angle AOB is equal to 65, so that's this angle, the angle adjacent to it, angle AOC, this angle is its supplement, so you subtract 65 from 180 and you get 115. So if that angle is 115, that's a central angle, and therefore its arc AC, is also equal to 115. So the measure of a central angle equals the measure of its arc, or the other way around. Next problem. Very similar diagram. The measure of the central angle is equal to 43. So therefore, if its intercepted arc AB, is also equal to 43, similar to the two previous problems, then the rest of the circle, arc ACB, is the rest of the circle. So it's 360 minus 43, which equals 317. So the measure of a major arc is equal to 360 minus the measure of the remaining minor arc, which is 43 degrees in this case. Next problem. The measure of angle AOB is now, again, in a central angle. It happens to be an obtuse angle this time. 120 degrees. We can add to the diagram. We can say its intercepted arc is equal to 120. Its supplement, 60 degree angle at angle AOC, its arc is equal to 60. The semicircle at the bottom is equal to 180. And we can now answer the question. The measure of arc BAC is the top half of the circle, which is 180 degrees. Next problem. Now we have an inscribed angle. It's an inscribed angle because the vertex is on the circle. And it's actually a theorem. It sounds a lot like a definition, but it is a theorem that states the measure of an inscribed angle is half of the arc. So angle ACB is an inscribed angle. So therefore it's 1/2 of the arc, or the arc divided by 2. So in this case that's 76 divided by 2. Angle ACB is 38 degrees. Next problem. We can have the angle is given as equaling 43. So therefore, to reverse the theorem, if we divide by 2 to find the angle, we multiply by 2 to find the arc. So 86 is the measure of the arc. Next problem. If the measure of the angle is equal to 37, what is the measure of arc ACB? Well, it's asking for this arc over here, arc ACB. The 37 degree angle tells us that this arc over here, which happens to be a minor arc in this case, is equal to 74, because just like the previous problem, you multiply the arc by 2, the angle by 2, and you'll find the arc. And therefore, if that arc is equal to 74, we can get rid of the angle, and we can simply say those two arcs add to equal 360. So you take 360 and subtract 74, and you get 286. for that answer. Next problem. The two types of angles put together into one diagram. So I'm just going to copy this diagram so I can get rid of part of it at a time. And we'll paste it down below here. We'll go back to the given information. It says angle AOB is 58. So angle AOB, I'm going to just look at that angle and say that equals 58. If that angle equals 58, because it's a central angle, its arc is equal to 58. Now I'm going to draw in the inscribed angle that I just erased a few minutes ago, and I'll get rid of the central angle, the given information, and I'll simply say now if it's an inscribed angle intercepting an arc of 58 degrees, then the angle, we'll call it x, x is equal to half of 58, so 58 divided by 2 is 29 degrees. So you only want to look at part of the diagram at a time, and makes it a whole lot easier if you can do just that. Next problem. Measure of angle BCA is 32. So now we're just going to reverse the steps. So once again, I'm going to copy the diagram so I can erase part of it and still have my original diagram. The inscribed angle is now 32 degrees. I think it was 32, was it? Yeah, 32. So if that angle's 32, I'll get rid of, for now, the central angle and say if an inscribed angle is 32, that's half of what number? And this is angle B, or point B. And therefore its arc is 64 because you multiply by 2 to find the arc. Now if the arc is 64, we can get rid of the inscribed angle and draw in again the central angle. And therefore if a central angle intercepts an arc of 64, the central angle itself is also equal to 64, because the central angle equals the measure of its arc. So the answer to the question, the central angle, angle AOB, is 64. Next question. The measure of angle A is equal to 115. Now we've done this problem two different ways in class. One way of doing the problem, once again I'm going to copy the diagram, and I'll go over this problem two different ways. The easy way of doing the problem is if an angle is given, such as angle A is 115, if it's an inscribed quadrilateral, which it is here because all four vertices are points on the circle, opposite angles for an inscribed quadrilateral are going to be supplementary. So supplementary means they add to equal 180. We subtract 115 from 180 and we get 65. And that is the answer to the question. Well, a lot of people don't remember that theorem, so I'll show you another way of doing the problem. That's the fastest way if you remember the theorem. The other way of doing the problem is this. If angle A, which is an inscribed angle, is 115, its intercepted arc, this arc, the angle has to be half of the arc, so therefore the arc has to be double the angle. So that arc, we'll get rid of this work over here, that arc highlighted in purple is equal to 230, which is 115 times 2. If that arc is equal to 230, I'm going to get rid of this angle now, and I'll state the other arc, we'll highlight that in green, that finishes off the circle, so therefore 360 degrees for the circle. If the purple arc is 230, we subtract 230 from 360 and we get 130. That's the green arc, 130. So now if that arc is equal to 130, we can get rid of all of this, and we can state the measure of angle C, which is an inscribed angle. That's an inscribed angle. The vertex is on the circle. It's half of the arc that it's intercepting. The arc that it's intercepting is 130. So 130 divided by 2 also gives you 65. And that's the answer to the question again. So that's two different ways of coming up with that same answer. Whichever one makes more sense to you is the way you should proceed on similar problems. And one more question. We also have a theorem about this. And the theorem states if an angle, like angle BCA, is inscribed in a semicircle, which means its endpoints are endpoints of a diameter, the angle has to be a right angle. Now we proved this in class, we illustrated in class at least, by drawing quite a few different angles all inscribed in the same semicircle, and they all turned out to be equal to 180. The reason being, the arc at the bottom half of the circle, this arc, it's half of the circle, so that's 180. Forget about the center of the circle. If that arc is 180 and angle C is an inscribed angle, the angle C in this case, should be half of 180, which gives you 90. So the measure of the angle is equal to 90 for either of those two reasons. Hopefully all of this helps you for tomorrow's quiz. Good luck.